Writing nuclear reactions. What this worksheet is talking about is how a radioactive substance will decay, will break apart either by beta emission or alpha emission. And there is information about this in your reading material, and it shows you some examples. And there's also two examples here, but in your reading material it also shows you the why, for why they change the way they do. So in alpha particle decay, if we have a nuclear reaction where you lose an alpha particle, what happens is that you have some radioactive element, and it is going to actually, the nucleus will break up a little bit, and you'll lose 2 protons and 2 neutrons from that substance, from that atom. So here we have radium-226. And see, you've got radium with a little hyphen here and 226. That means this is the mass of radium. It's an isotope of radium with a mass of 226. So if you look at your periodic table here, radium does have a mass of 226 normally, but they won't all be this way. For example, on polonium here, PO, it has a mass of 209 according to my periodic table, and here I'm talking about polonium-210. So don't get your mass from the periodic table for these isotopes. Always take the mass that is given in the name of the isotope. So here we have radium-226, radium-226, and we put that 226 on top as the atomic mass, and then we put the atomic number of radium here, which is 88. And remember, your atomic number is the top number on your periodic table box for that element. And it's going to lose 2 protons and 2 neutrons. Well, our atomic number tells us the number of protons, so it loses 2 from the atomic number. Our atomic mass tells us protons and neutrons together, so since it loses a total of 4 particles, 2 protons and 2 neutrons, then our mass goes down by 4. And so our new atomic number is 86, so we have to look at our periodic table, find element number 86, and put the symbol for that element, Rn. And what leaves the nucleus of that atom looks like a helium nucleus. It's 2 protons and 2 neutrons, so helium is atomic number 2, 2 protons plus 2 neutrons would give me a mass of 4. So it says here why? Well, because 226 minus 4, 226 minus those 4 gives me 222, and 88 minus the 2 protons gives me the 86. And you can see here's another example, polonium-210, mass goes down by 4, the atomic number goes down by 2, and a helium nucleus is what is released. And you can see on your worksheet, same thing here, dubnium-262 decays by alpha emission. Atomic number of dubnium is here. It's going to lose a mass of 4, 2 of them being protons, and that is what is released from the nucleus in this type of nuclear decay. In beta decay, I'll show you the examples down here. In beta decay, what actually happens is that one of the neutrons is transformed into a proton and a beta particle, which is basically an electron. So if you look at the examples here, our mass stays the same because a neutron changed into a proton and an electron. The electron will leave the nucleus, but the electron doesn't have enough mass to change our total mass here. An electron has a mass of a very, very small amount compared to the mass of a proton or a neutron. So it counts as 0 mass here because it's so much smaller than our protons and neutrons. So in this case, because one of our neutrons, though, from this mass became a proton, our number of protons goes up 1. So we actually have 1 more proton because a neutron became a proton, but our mass doesn't change because the mass of a neutron and a proton is almost exactly the same. So what happens is we lose no mass, All right, but we have this -1 here to make up the difference between going from an 83 to an 84, and we put an E for an electron, which is the beta particle that leaves the nucleus. So again, we have the decay of lead-210, same thing, mass stays the same, atomic number goes up 1, and this is what leaves the nucleus. So when you do yours, I'll do one with you. Krypton 87 decays by beta emission. So I take Krypton 87, Krypton is Kr, and I find that on my periodic table. Its atomic number is 36, so that'll go on bottom, and it says Krypton 87. Don't use this 84 from your periodic table because that's not the isotope of krypton we're talking about. We're talking about this radioactive isotope, Krypton 87. So Krypton 87 with an atomic number of 36 is going to undergo beta decay. So I know that in beta decay, my mass stays the same, so I keep it as 87. My atomic number goes up 1, so I'm going to go from 36 to 37, and now I have to find what element that is. Atomic number 37 is right here, rubidium, it's Rb, so I write Rb, and then write out the beta particle that leaves the nucleus. And I know that I've got this right because 0 plus 87 is 87, and -1 plus 37 would give me the 36, and number 1 is done. So go ahead and do all the way through number 10 the same way. Follow the pattern for either beta or alpha emission, and if you do still have any questions about how to do these, please come ask.